Hello dear subscribers, अब चलते हैं. Let us discuss one more numerical problem on parallel forces and couples, moment of the couple. Problem set 3.1, solution to 3.8, very simple. Now before I read out the problem, look at the diagram. ABC is a crane and this is a cement surface. The crane is anchored to the cement surface at A, foundation at A. Two couples act on the crane as shown in the figure. Determine the resultant couple moment. Now, so look here, there is a force P here, there is a force P here. This angle is given as alpha and this length is B. And this length B is not the perpendicular distance between this P and this P. The perpendicular distance between this P and this P will be from here to here in this manner. So B is not the perpendicular distance. Similarly here, this angle is given alpha. Similarly here there is a force Q and there is a force Q here, and D is the distance between this point and this point, and obviously not the perpendicular distance between Q and Q. So look at both the forces, P here and P here. As I explained, B is not the perpendicular distance between these two forces P and P. So then which is the perpendicular distance between P or P? Between this P or this P? Or, so instead of doing that, now let me resolve these two P's into two rectangular components. You look here. This angle is given alpha, this P is parallel to this P. So if I extend this line, like this, so this will also be alpha. So this is your P, this will be your P times cos alpha, and to this side will be your P times sin alpha. Similarly, if this is P, this will be your P times cos alpha, and to this side will be same P times sin alpha. So the P sin alpha component of this P and P sin alpha component of this P, they act along the same line, means they don't have a perpendicular distance. Therefore these two don't produce any moment or any couple. And between P cos alpha, this P cos alpha of this P and this P cos alpha of this P, this is vertically down, this is vertically up, so the perpendicular distance is B as is given here. So due to this P cos alpha and this P cos alpha having a perpendicular distance B, there will be a clockwise torque turning effect. So let it be C1. So it will be P cos alpha times B. Now then come back to the two forces, Q here and Q here. Now given this angle is beta, if you extend like this, then this angle will be beta. This angle will be beta, vertically opposite, and Q is like this. So I have shown it here. So this is your Q, this is your beta. So if you make components like this angle will be beta. So this will be your Q times cos beta, and this will be your Q times sin beta. Similarly, the Q here. Now this angle will be beta. Now so if this is Q as shown here, this one will be your Q times cos beta, and this one will be your Q times, this one will be Q times sin beta. So Q cos beta and Q cos beta, they act along the same line. Actually, I should have resolved it here. If you resolve it here, then this will be This will be your q cos beta, this will be your q sin beta. So if you resolve it here, this will be your q cos beta and this will be your q sin beta. So both q cos beta, they act along the same line, they don't have a perpendicular distance between them. So the q cos beta component of both this q and this q, they don't produce any couple. And q sin beta and q sin beta, they are anti-parallel, and the perpendicular distance between them is the same thing as from here to here, that is d. So it will produce an anti-clockwise. So d is the perpendicular distance between two q's, q sin beta and q sin beta. So it will produce an anti-clockwise couple. So since the perpendicular distance between them is d, so the couple, anti-clockwise couple C2 is equal to q sin beta times t. Now, so the net couple will be one minus the other. So net couple C is equal to C2 minus C1. I have taken C2, that is the anti-clockwise torque couple as positive and C1 as negative. So just subtract. So this comes out to be QD sin beta minus PB cos alpha. QD sin beta minus PB cos alpha is your net couple that is acting on the crane. So I think it is clear to you. Thank you very much.